Hi, welcome to my channel. In this channel, I'm going to make a series of videos related to different topics related to FPGA, Verilog, VSTL, MATLAB, Python, C++, and many more. Please subscribe this channel. Today, we are going to design a basic Verilog project in Vivado for beginners. For this purpose, I choose to design the half adder. Half adder is the very basic digital circuit we can easily design in Verilog. And then we will show you how you can instantiate the half adders to make a full adder. As you can see in the schematic, there are two half adders, and some of these gates make the full adder. Okay, so I will just run the Vivado. Now I'm going to create a new project. This is project half adder. Can keep it as default, or if you want to implement on FPGA, then you can select the FPGA as well. Okay. Now I will write a half adder Verilog code. Okay. Now you can see there's only two inputs A and B, and XOR of this input we get the sum, and end of this input we get carry. Okay, if both A and B are 0, then both carry out and sum will be 0. If any of input is 1, then carry will be 0, sum will be 1. If both of input are 1, then carry out will 1 and sum will 0. It means we have only two input A and B. Output are sum and C out, carry out. Okay. There are multiple ways we can write code. I'm going to design with assignment statement. Assign sum is equal to A XOR B. Assign we can denote that XOR like this, and C out is equal to A and B. Okay, this is quite simple. Okay, I will make it force simulation value. I will put A and B value by force, so I don't need to write any test bench for it, as I have implemented in previous lecture, then how we can put force value. Okay, so for now we will put force constant value of, first I will put is 0 and force constant value of b, both are 0. Now you can see that if both values are 0, then sum and carry are 0 0. Okay, now I will put a is 1. Then what if, now you can see that if a is 1, b is 0, sum is 1, but carry out is 0. If I will put b is 1 and sum is a is already 1. So what it, you can see that if both a and b are 1, then sum will be 0, carry will be 1. Okay, in this way you can implement the half adder in Verilog. Now I will show you how you can design full adder by instantiating the half adder. Okay, for that I'm going to write a code for full adder. As you can see, in a full adder there are three inputs and third input is carry in. We usually name this input carry in. Okay, and you can see the output is the sum of these three inputs. If all of the inputs are 0, then sum and carry will be 0. If one input is 1 and rest of 2 is 0, then sum will be 1, carry will be 0. Yes, same for this case. If two of input is 1, only one is 0, then carry will 1, sum will 0. Okay, and this is the another case. If only one input is 1, 2 is 0, then sum is 1. In two inputs are 1, if one input 0, then carry will 1, sum is 0. Same for this case. If all inputs are 1, then sum will be 1 and carry will also 1. Your input A, B, C in, okay, output is sum and carry. Okay, and now I will instantiate one half adder for this circuit, one half adder for this circuit. So there will be a one intermediate signal over here, one intermediate signal over here, one intermediate signal over here. Okay, carry of both half adder will be OR at the end to generate the carry out. Okay, so I will make three intermediate signal. This will be some temporary value of sum. This will be temp carry 1. This will be carry 2, and this will be C out carry. Okay, I will instantiate the half adder. This is my half adder. Okay, first I will write a intermediate signal carry 1, carry 2, and some temple. Okay, this is for just intermediate signals. Then I will call the half adder which is I designed instantiate instant 1. Okay, uh, how you can instant first you will call the a. This a represent the this a. Okay, and inside this bracket you will name the current input. Okay, secondly b with b, like that. What will be the end? There will be sum, there will be C out. Okay, sum will be, according to this, the sum will be our temp sum. Okay, so I have created the intermediate signal temp sum, and similarly the there I named C out. Okay, C out will be the carry 1. Okay, this intermediate signal I named as carry 1. Okay, in this way we can just call one half adder. Okay, similarly I will call half adder with name instant 2. The input of a, this a input will be the temp of this sum. Okay, so I will just put temp sum will be the input of this half adder. Okay, the second input of this sum will be the C in. So this is the C in, and third is sum. Now the sum of this half adder will be the final sum. Okay, so I will just name this sum will be the final sum. Now the carry. C out will be the carry 2. Okay, because we have to, or the both of carries, carry 1, carry 2, so that carry 2 will write like this, and we will generate our final output carry equal to carry 1 or carry 2. Okay, carry 1 or carry 2. You can see that it instantiated instant 1 for half adder and in instant 2 again half adder. Okay, you can see its RTL schematic. Here you can see that carry is the OR gate of both carry out of both half adders, and this is the sum. Inside this, you can see the or half one half header is instantiated inside this instant and one inside this instant. Okay. Now I will show you its simulation. I will just put its force value. Force constant 0, constant 0, force constant 0. If all inputs are 0, then I will just remove these intermediate signals. Okay. If A is 1, yes, you can verify the table. If either one input is 1 and two inputs are 0, then sum will be 1. If either in this case, in this case, in this case, only one input is 1. Okay. So sum is 1, carry are 0 for that case. If two inputs are 1, like this, or like this, then our sum will be 0, carry should be 1. If I will make B1 as well, then you can verify that both A and B are 1, then our C is 0, sum will be 0 and carry will be 1. For example, if I will put C is 1 as well, now you can see that if all inputs are 1, then sum will be 1 and carry will be 1. Okay, in this way you can write full adder Verilog code by instantiating the half adders. Okay, please subscribe this channel. I will make more videos from basic to the advanced. Thank you very much.